If your vehicle specifically requires premium fuel and you regularly use regular unleaded to save money, you are causing measurable long-term damage to your engine that will cost thousands more than you saved on fuel. According to automotive engineers and engine management specialists, engines designed to require premium fuel experience chronic knock that degrades pistons, valves, and combustion chambers when forced to run on lower octane fuel. While modern knock sensors prevent immediate catastrophic failure by retarding ignition timing, this protective measure reduces power output by 8 to 12% and decreases fuel economy by 6 to 10%, meaning you're not actually saving money while you accelerate engine wear. Independent testing by automotive laboratories has documented that high compression and turbocharged engines running regular fuel when premium is required develop carbon deposits 30% faster, experience measurably increased cylinder wear, and show reduced engine life of up to 20% compared to engines using the specified premium fuel. The critical distinction is between engines that require premium versus those that merely recommend it. If your owner's manual says premium fuel required or premium fuel only, using regular fuel causes progressive damage. If it says premium recommended, regular is acceptable with minor performance loss. Keep watching because I'm going to explain which specific engines absolutely require premium, what damage occurs from using regular fuel, how to identify if your engine needs premium, and whether the fuel cost difference justifies the risk. Hey, if you like this kind of straight-to-the-point content with no BS, help me out here. Subscribe to the channel right now. It takes 2 seconds and guarantees you won't miss any tips that could save you some serious cash. Let me start by explaining which engines require premium fuel and why this requirement exists. Premium fuel requirements are not arbitrary marketing decisions. They are engineering necessities based on how the engine is designed. 3 types of engines typically require premium fuel. First, naturally aspirated engines with high compression ratios above 10:1. High compression means the air-fuel mixture is squeezed more tightly before ignition, generating more power from each combustion cycle. However, higher compression also creates more heat and pressure, increasing the likelihood of pre-ignition or knock. Premium fuel with its higher octane rating resists this premature ignition. Examples include Corvette with its LT2 V8 engine using 11.5:1 compression, many BMW M models with naturally aspirated engines, Porsche naturally aspirated flat 6 engines, and various high-performance vehicles. Second, turbocharged and supercharged engines require or recommend premium because forced induction dramatically increases cylinder pressure. When a turbocharger or supercharger forces more air into the cylinders, compression pressures rise significantly even if the static compression ratio is moderate. This increased pressure creates knock tendency requiring higher octane fuel. Most modern turbocharged engines fall into this category, including Ford EcoBoost engines in many applications, BMW turbocharged inline 4s and 6s, Audi and Volkswagen turbocharged engines, and many others. Third, some luxury vehicles require premium, even with modest performance, because manufacturers tune the engines specifically for premium fuel to achieve desired refinement, smoothness, and power characteristics. Now let me explain what knock or detonation actually is and why it damages engines. Normal combustion occurs when the spark plug ignites the air-fuel mixture at a precisely controlled moment. The flame front spreads smoothly across the combustion chamber, pushing the piston down. Knock or detonation occurs when remaining unburned mixture ignites spontaneously before the flame front reaches it, creating multiple flame fronts that collide. These collisions create shock waves that produce the knocking or pinging sound and subject engine components to extreme localized pressures and temperatures. Modern engines have knock sensors that detect this and command the engine computer to retard ignition timing to prevent knock. This works to prevent immediate damage, but it comes at a cost. Retarding timing reduces power output typically by 8 to 12%. It also hurts fuel economy by 6 to 10% because combustion efficiency decreases. Most importantly, chronic low-level knock that the sensors detect and suppress still causes cumulative damage over time, even though the knock control prevents catastrophic failure. The specific damage mechanisms from using regular fuel in engines requiring premium include several distinct processes. First, carbon deposit formation accelerates significantly. Independent laboratory testing has shown that engines running lower octane than specified develop carbon deposits on pistons, valves, and combustion chamber surfaces approximately 30% faster than engines using proper fuel. These deposits create hotspots that further increase knock tendency, creating a worsening cycle. Carbon buildup reduces engine efficiency, causes rough running, and eventually requires expensive cleaning services costing $500 to $1,500. Second, piston damage occurs from repeated pressure spikes, even with knock control preventing audible knock. The higher cylinder pressures from running on the edge of detonation stress piston crown and ringland areas. Over tens of thousands of miles, this causes micro-cracking and accelerated wear. Third, valve damage results from increased combustion chamber temperatures. Engines running at knock threshold experience higher peak combustion temperatures. Intake and exhaust valves operate at these elevated temperatures, accelerating valve stem wear and valve seat recession. Fourth, spark plug life decreases due to the higher electrode temperatures from elevated combustion temperatures. Spark plugs may need replacement twice as often. Fifth, and most significantly, overall engine longevity decreases. While difficult to quantify precisely, engine specialists estimate that high compression or turbocharged engines regularly run on insufficient octane fuel may experience 20% reduced service life. An engine designed to last 200,000 miles might show serious wear by 160,000 miles. The fuel economy penalty deserves special attention because it directly affects the money-saving calculation. Premium fuel typically costs 40 to 60 cents more per gallon than regular. In a vehicle with a 15-gallon tank, that's $6 to $9 per fill-up. However, if using regular fuel decreases fuel economy by 6 to 10% as testing shows, you're buying more fuel to travel the same distance. For example, a vehicle achieving 25 miles per gallon on premium might only achieve 23 miles per gallon on regular. Over 10,000 miles annually, that's 435 gallons on premium versus 435 gallons on regular. Wait, let me recalculate that correctly. 10,000 miles at 25 mpg requires 400 gallons. At 23 mpg, it requires 435 gallons, meaning 35 extra gallons annually. At $4 per gallon, that's $140 in extra fuel consumption, nearly offsetting the premium fuel cost difference. Now let me explain how to determine if your specific engine requires premium versus merely recommends it. Check 3 locations on your vehicle. First, inside the fuel door, there's typically a label stating fuel requirements. Second, your owner's manual fuel section specifies requirements clearly. Third, some vehicles display fuel requirements on the instrument cluster near the fuel gauge. The exact wording matters critically. If it states premium fuel required, premium fuel only, or minimum 91 octane, your engine is engineered to require premium and you should use it. If it states premium fuel recommended, premium fuel for best performance, or similar language, your engine can safely run regular with minor performance reduction. The recommended designation means the manufacturer designed flexibility into the engine management system. These engines can adjust timing and other parameters to safely run regular fuel, though you'll lose 5 to 10% of peak power and possibly experience slightly reduced fuel economy. Many modern turbocharged family vehicles fall into this category. They run fine on regular, but unlock full power with premium. For these engines, the choice is yours based on whether you value the extra performance. For engines requiring premium, the choice is clear. Use premium fuel. The long-term costs of using regular far exceed any short-term savings. Let me provide specific vehicle examples. Vehicles that require premium include Chevrolet Corvette all models, BMW M Series all models, Porsche 911 all models, most Audi S and RS models, Mercedes AMG models, and many luxury sports sedans. Vehicles that recommend, but don't require premium, include Honda Civic Type R, which requires premium for full power, but can run regular safely. Many Ford EcoBoost equipped vehicles where the manual states recommended, not required. Some Mazda Skyactiv turbocharged engines, Acura TLX with the turbocharged engine, and various other turbocharged family vehicles. When in doubt, follow the owner's manual exactly. Some additional considerations. If you're buying a used vehicle, verify fuel requirements before purchase. Factor premium fuel costs into your ownership budget. If premium is required and you can't afford the ongoing fuel cost, choose a different vehicle. Don't buy a car requiring premium thinking you'll just use regular to save money. You'll spend more on repairs than you save on fuel. If you're in an area where premium fuel is unavailable temporarily, you can use mid-grade or even regular for short distances to get somewhere with premium available. The knock sensors will protect the engine for limited mileage, though performance will suffer. Don't make this a regular practice. Some people try using octane booster additives from auto parts stores with regular fuel to avoid buying premium. Most over-the-counter octane boosters only raise octane by 1 to 3 points, which isn't enough. A bottle might take 87 octane to 88 or 89, but not to the 91 or 93 required. These additives aren't a substitute for proper fuel. If you've been using regular fuel in an engine requiring premium, switching to premium now will prevent further damage, but won't reverse damage already done. Carbon deposits can be cleaned professionally. Worn components will continue wearing, but proper fuel prevents acceleration of wear. So here's the bottom line. If your engine requires premium fuel, as stated in the owner's manual, using regular fuel causes measurable long-term damage, including accelerated carbon buildup, increased engine wear, reduced performance, decreased fuel economy, and shortened engine life. The fuel economy penalty of 6 to 10% means you're not saving as much money as you think while you damage your engine. Engines that recommend premium can safely use regular with minor performance loss. Always follow your owner's manual fuel requirements. The few $100s annually you might save on fuel will cost thousands in premature engine repairs or replacement. Use the fuel your engine was designed for, and it will provide reliable service for 200,000 miles or more. Use the wrong fuel, and you're gambling with expensive repairs.